Good day. So the topic we're looking at to start this term is geometry. Just our definition here is that pattern maths are going to focus with lines, angles mainly, and then you'll see some shapes and solids, and obviously points going to come into that. So an angle is a measure of turn, and again to be in degrees, so that little symbol there is what represents degrees, and it's formed when two lines meet. So once we have two lines meeting, it don't matter how these two straight lines meet, you're going to get angles. This is going to be the angle inside here, and we'll talk a little more about that when we're looking at some other topics. So here we have just some basic background information before we actually start would be types of angles. So some of the types of angles we have is a acute angle less than 60. So again, we start here and we turn. So if this counts as our starting point and we turn in this arm, that angle is less than 90, because this will be 90, 180, 270, and when we make the full circle, 360. So again, these are just sketches to show you what a acute angle would look like. A right angle is 90 degrees and to be represented by a box. This will be a popular situation that we're coming across. Obtuse angle, again, it crossed the 90 but it didn't reach the 180, so this will be the obtuse angle. A straight line or a straight angle is just a straight line, and it's 180 because it's really half the circle. If you notice, a circle is 360, so half the circle would be 180 degrees. It come like we cut that circle in half. And a reflex angle, as you can see here, will be more than 180 because it crossed the straight line but it didn't make the full circle, 360. So that's just some terms you'll come across. What we're going to look at next are the rules, because this topic going to be heavy on rules. So properties of angles and straight lines. The first and most basic geometry rule: angles on a straight line going to add up to 180. And again, we saw a straight line already was half of the circle. So that means no matter how you split it, we can split it 3 ways, we can split it 2 ways, whatever these two angles are, have to make up half the circle, which is a straight line, which is 180 degrees. So that's the first and most basic rule. It seems pretty simple enough, but you'll see how it comes into play with other rules a little bit later on. So if you want to calculate the size of angle x, just some examples to show you. So it have the easy way and it have the long way. Now the easy way means you're doing this in your head because you already know these two pieces have to add up to 180. So how much I need to add to 40 to make 180? 180 take away 40, 140. Or I could use this same template we have here, which is these two pieces, or how much ever pieces they are. In this case is two pieces, x and 40, forming half the circle, which is a straight line, 180 degrees. And then using my algebra solve, I carry that across. So x will be 180, take away 40, so I get 140. So that's using it more mathematically than just looking at it and doing it, which is an option you have as well. Same thing here, we already see the box from earlier was 90 degrees, that's a right angle. And two right angles make up 180, half of 180 is 90, so the answer is going to be 90. Or you could do it just like this. The real one I want to look at is this one. You realize this one have just variables, no numbers like the other two. So that's where this method from earlier going to come up and be a little more helpful. So we know whatever these are, the two pieces have to add up to 180. So 2x plus x or 1x is 3x equal 180. So x will be 180 divided by 3. So each angle is 60 degrees, meaning x is 60, and he's going to be 2 times 60, which is 120. And let me just double check. 120 at 160, sorry, 120 at 60, giving me the half a circle, which is 180. Second rule. So that was the first rule, very basic, very straightforward. Second rule, when two straight lines intersect or cross, that's just a fancy word for cross, the opposite angle is going to be equal. And these are just different variations where we have where two straight lines intersect. They can intersect in different ways, but once two straight lines cross, this rule is going to apply. So let me just give these some letters so you'll see it a little better. So we're calling these angles A, B, C, D. So what they're saying is, well, one, we have a full circle here if you notice. But it's saying the opposite angle is going to be equal. So that means since A and C facing each other, vertically opposite is the term they really use, A going to equal to C. And since B and D, they facing each other, B going to equal to D. But if you notice here, the rule from before, the very first rule, still in play here. So we have a straight line here, so that means A and B still going to add up to 180. We have a straight line here, so B and C still going to add up to 180. Same thing, C and D going to add up to 180, A and D going to add up to 180. And again, all four angles in this case going to total 360 because all four of them making a complete circle this time, if you notice. And again, it don't matter how we write it or what letters we use. If I was calling this W, X, Y, Z, what's going to be the opposite angle? So they really cross at the center. So W and Y going to be equal, and X and Z going to be equal. Although in this one, all the angles would have been 90, 94 is a 360. And again, just to show you one more example, A, B, C, D, these two going to be equal, and these two going to be equal as well. Let me see it a little better in an example though. So I have two straight lines intersecting or crossing, and I want to determine the size of the angles marked with the letters. So I have different ways I could do it. If we're using this rule here immediately, then these two opposite each other, so I know 80 degrees going to equal Z, and these two opposite each other, so I know X going to equal Y, but I don't have either of those, so that's where the first rule, and that's why the most basic rule, comes into play. Since this on a straight line, and you find your straight line that it's on, you realize this on a straight line here. If I was to cut off this other part here, this on a straight line, again, maybe you're not seeing it as well, but if I straighten it up a little bit, look, I have it on a straight line there. It just, these two pieces have to add up to 180. So X plus 80 going to be 180, and you can see it. So X will be 180, take away 80, so X is 100, because 100 plus 80 going to equal 180. So X is 100, and because X is 100, Y going to be 100 as well, because both of them is the same. And if you wasn't sure, you could double check it yourself, because if I'm looking at it from this side now, and I wanted Y, this is my straight line now. These two pieces have to add up to 180, which is half the circle. So 100 plus 80, giving me the 180. And same thing here. If here is 80, you could double check it how much you want. 100 plus 80, 100 plus 80. So however you want to check that, that's what it would look like. So don't forget that first rule, because you're going to see it popping up a lot. So this was the second rule. So the opposite angles was X and Y, 80 and Z, and X and Y, each piece would be equal to 100. Last of the main rules, well, this is really the big rule, and it has to do with parallel lines. And from this situation with parallel lines, we have 3 sub rules. So it's really 5 basic geometry rules, as you'll notice. And this one is when two parallel lines, and you'll know lines parallel in your diagram because they'll give you these arrows. So once you see these arrows, you don't have to use the words parallel. It automatically means those lines with the arrows would be parallel. If it had more than one pair of parallel lines, the second set of parallel lines would have double arrows on it to let you know that those different from this set of parallel lines with one pair of arrows, as you'll see when we're doing some of the other questions. So when two parallel lines are cut by another line, and I'm just going to put in some letters here. So we have A, B, C, D, and let me call the bottom W, X, Y, Z. So you realize we still have the first rule here. I still have a straight line, a straight line, a straight line. And we still have the second rule here, because this is two straight lines intersecting, and we have A equals C, B equals D. The only difference now is we have two sets of them. One on the top and one on the bottom. They're joined by this third line, which we call a transversal. And they're running on parallel lines as well. And from this, we have 3 rules. And the first rule from this situation is corresponding angles. So corresponding means in the same position. So angles that are in the same position on the piece on the top and the bottom, so they have to be in the same position, going to be equal. So again, if I was to write back A, B, C, D here, and W, X, Y, Z here, what on the same position on the top piece, because remember, it have a top circle now and a bottom circle that joined by this line. The same position on the bottom piece, top left, here on the top left, but on the bottom piece. So that means A and W would be corresponding angles because they're in the same position. What in the same position as B? So B and X in that same position, so B and X will be corresponding angles. What in the same position as C? C and Y in the same position, so they will be the next pair corresponding angles, and D and Z in the same position. So once you're in the same position, on the top and the bottom, but for this situation you must have a top and a bottom, and all the diagrams won't have a top and a bottom. So this is not one of the more popular ones that you might encounter. The most popular one that you tend to encounter is the alternate angle. Alternate means opposite, so alternate angles mean on opposite sides of the line segment, but because they're on opposite sides and we have the parallel lines, they tend to look like a Z shape. So once I form in some kind of Z shape with the parallel lines, that's a proper Z. We could have a back to front version of the Z. We could have a stretched out Z, and we could have a back to front version of the stretched out Z. Once I have something forming a proper Z shape or a back to front stretched out Z shape, the lines on opposite sides or alternate sides of this going to be equal. So those two pieces inside, they're going to be equal. Opposite sides of that line segment, these going to be equal. Opposite sides of that line segment, these going to be equal. So that's why we call this whatever it looks like a Z for alternate angles. It starts with A, but it ends with Z because that's what it's going to look like. And again, we're using the same letters: A, B, C, D, W, X, Y, Z. And we want to know what's going to form the alternate angle. So I'm just going to trace out the Z. So you have to train your eye to see the Z. I'm just going to highlight a possible Z there. So that's the Z looking shape that we're going to get there. Is an actual proper Z in this case. And again, it's on opposite sides of that drawn line. So this angle on this side and that side between the parallel lines. So whatever in the arms of the Z they say, those two pairs are the alternate angles, and those two angles therefore will be equal. And that's the name of that Z-shape rule, alternate angles. Do we have any other Z's in this shape? Yes, it's probably a little hard to see, but we have this back to front stretched out Z. So if I was to do this back to front stretched out Z, again it's sharing that same line, but this is the Z I'm looking at now. So these two angles are going to be equal, so that means the D and the W are also going to be alternate angles and equal. The last one I need to look at is the interior angle. And the interior angle, unlike the other two, corresponding was equal, alternate was equal. Interior angles add up to 180, right? So they add up to 180. A fancy word for add up to 180, by the way, is supplementary. They don't use it as much anymore. Complementary means it adds up to 90, but supplementary means add up to 180. So again, A, B, C, D, W, X, Y, Z. So interior means on the inside of the parallel lines. So once I have angles on the inside of the parallel lines blocked off, so let me look at it here. So I have the parallel lines and they're blocked off by this line here. So the angles on the inside, think a shape, because I could have finished off a shape here, get a trapezium if I draw a line down, or some other four-sided shape, or a different kind of shape as well. I could these two angles here are going to add up to 180. So C and X going to add up to 180. So that's what interior angles are. The angles on the inside, so you're going to add up to 180. And same thing on the next side, because I had a separate pair on this side. They on the inside of the parallel lines as well, and they blocked off here. So they on the interior, but on the next side of the line. So D and W would have also added up to 180. So we have those two options. So these are the rules. Next up, we're just going to look at some examples, because I realize this video running a little long already. So the next section, we'll just look at some questions on these.